Hello, my name is Noah Judy, and this is my Lab 3 report, data and analysis. So for the setup of this lab, we were tasked with predicting the behavior of circuits containing resistors in both series and parallel, and we had to use multimeters to measure the actual values of conventional current and potential differences in these circuits, and we also had to examine the behavior of ohmic resistors and capacitors. And so this experiment involved creating various circuits and recording various metrics, including current and potential differences. And here's a little schematic of the experiment here. Our net voltage was 0 volts, and here's the equation explaining that. And then here in this picture on the whiteboard, you can see the placement of the different resistors and the battery. So some important principles we used during this experiment were the principles of system versus surroundings, the system being the circuit being observed and the surroundings being pretty much everything else, desk, air, us. The loop rule was something that was very important to us. Here's the equation for that right here. Node rule also came in pretty handy, and here's the equation for that. And also Ohm's law, the change in voltage equals IR. And the current predictions for this experiment. So total voltage, we had two 1.5 volt batteries, so 3 volts. Resistors, that gave us a total of 147 ohms. We calculated our amps to be 0.02, just dividing the voltage by the resistance. And then we measured our current to be 0.096 amps. This was using only one battery. And then here's another picture of our experiment. Here you can see the whiteboard drawing of the circuit. And then on the right here, you can see us using the multimeter to measure the current in the circuit. And then here's a diagram showing you the current along various points in the circuit. They're all labeled. You can see when we measured it around the battery, when we measured it around the resistors. And then here's another diagram showing the RC circuit. Procedure, we created the RC circuit with each bulb. We measured the charge and discharge time using a stopwatch. The components of this experiment were a 10 ohm bulb, a 20 ohm bulb, a 9 volt battery, and a capacitor. We found the charge time to be around 4 seconds and the discharge time to be around 40 seconds. Some possible errors in this experiment were only using one battery for the first circuit, also completing some of the lab with a real circuit and some of it through an online simulation that could be the cause of multiple discrepancies in our findings. And objects such as the desk touching the metal part of the circuit and affecting the results is something that is very likely. And so further questions: what happened if we charged a capacitor with no resistance in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. Use an ammeter to measure how long it takes to charge the capacitor when connected directly to the battery. So theoretically, no resistance. And discuss why the measured time is different from the predicted time. And the ideal model would have the capacitor reach full charge almost instantaneously, as there is no resistance. However, we know this is not possible. There's always going to be some form of resistance, including in the wire. So in real life, it would be quicker, but definitely not instantaneous, as there still is going to be some resistance. And this was my Lab 3 report and data analysis. Thank you.